Use this video clip to help you understand how to calculate percentage yields. Pause it and replay it as much as you like until you're happy that you've fully understood. We have two aims here. Firstly, to be able to calculate percentage yields. This means understanding the concept and being able to carry out calculations. And secondly, to be able to use mole calculations to find the maximum theoretical yield. You could be asked to do this in an exam question. So let's start by thinking about what percentage yield is. It's a measurement of how good a reaction is. It compares the mass of product made, which we call the actual yield or yield, with the maximum theoretical yield. This is the yield that in theory could have been obtained, and we usually work it out using a mole calculation. The mathematical expression that you need to learn is shown. The percentage yield is equal to the yield divided by the maximum theoretical yield multiplied by 100 because it's a percentage. Let's have a look at an example together. In this question, ethene has reacted with steam to produce ethanol, C2H5OH. A mole calculation shows us that 28 grams of ethene could produce 46 grams of ethanol. A student carries out the reaction in the lab and finds that only 32 grams of ethanol are made. We need to find out what the percentage yield is. To start with though, we need to identify which numbers are which. We need to know which mass is the yield, the actual yield obtained, and which mass is the maximum theoretical yield. So let's have a look. The product that we're trying to make is ethanol, so the masses we need must be to do with ethanol. If we read through it, the student finds out that he can only make 32 grams of ethanol. This must therefore be his yield. The maximum theoretical yield is from the mole calculation. So the second sentence says a mole calculation shows that 28 grams of ethene, the reactant, could produce 46 grams of ethanol. That 46 grams must therefore be the maximum theoretical yield. So let's do our working out. Percentage yield equals 32, the yield, divided by 46, the maximum theoretical yield, times 100. And if we do that on our calculator, we get the answer 69.6%. It's always good to write our answer to 3SF. We could be asked in a question for reasons why the yield is not 100%, so let's think through some. Firstly, the reaction may be reversible. That means that the backwards reaction can happen as well as the forwards reaction. So once the forwards reaction has happened, it may be that some of the products then react back to form reactants again. This obviously is going to mean a lower mass of product than we expected. Another possibility is that some of the product may be left on the apparatus or in the reaction mixture. This is particularly the case where we have to do complicated separating techniques to get hold of the product. And another possibility may be that there are side reactions happening. This means reactions that we weren't necessarily expecting, and it's often the case in organic chemistry. Now we know reasons for why our yield is going to be less than 100% in reality. Make sure you've learnt these so that you can answer a question in an exam. Let's now look at what we would do if we were asked to calculate the maximum theoretical yield. Here's an example. Okay, so in this question we are looking at the fertiliser ammonium sulfate and how it's made. We're given a balance symbol equation, which is going to be really helpful, and we're asked to calculate the maximum theoretical yield that could be made by reacting 85 grams of ammonia. We're told that there's an excess of sulfuric acid. That means more than we need, so we don't need to worry about the sulfuric acid. The first thing that we need to remember is that we can't go directly from one mass to another. We have to always go via moles. So the first thing I'm going to do is work out the number of moles of ammonia that we've got. To do that, I'm going to need to work out the MR value, the relative formula mass of ammonia. So let's do that first. So MR of ammonia is 1 times 14 plus 3 times 1. That's because we've got 1 nitrogen atom and 3 hydrogen atoms. and that gives us a total of 17. It's always worth writing in your MR values because examiners often look for them and give you method marks even if you get the rest of the answer wrong. I now need to work out the number of moles of ammonia I've got. So I use moles equals mass over MR, and my mass of ammonia is 85. So my moles of ammonia equals 85 over 17. Let's put that through our calculators, and we get 5 moles. Now the next stage is to look at the balanced chemical equation, because if we look at it, 2 moles of ammonia on the left here result in 1 mole of ammonium sulfate being made. I'm looking at the mole ratio, and I can write it out. It's a 2:1 ratio of ammonia to ammonium sulfate. Now that means if I want to go from ammonia to ammonium sulfate, I'm going from 2:1. I'm dividing by 2. So the moles of ammonium sulfate must be half of 5, i.e. 2.5. So moles of NH4, and it's always worth writing out your working really nice and clearly. .5 moles. Now I need to get my theoretical yield, my maximum theoretical yield in grams, and at the moment I've got it in moles. So my final stage is to convert moles to mass, and I rearrange my mole equation, so mass equals moles times MR. So I now need to work out the MR of ammonium sulfate, and that is 2 nitrogen atoms, so 2 times 14, plus 8 hydrogen atoms, so 8 times 1, plus 1 sulfur, so 32, plus 4 oxygens, 4 times 16, and I'm going to have to put that through my calculator again, and it gives us 132. So since mass equals moles times MR, our maximum theoretical yield is going to be our moles, 2.5, times 132, and we get 330 grams, and that's going to be my final answer. Let's move on to part B then. So we know how to find out the percentage yield, and we're told that only 300 grams of ammonium sulfate was produced. So I go back to my equation, my mathematical expression, percentage yield equals yield divided by maximum theoretical yield. So the yield is 300 grams. The maximum theoretical yield we just calculated in the previous part, and that was 330, and then times 100 because it's a percentage. And that gives us 90.9%. And once again, always worth just putting it to 3SF and making sure it's all really nice and clearly laid out. Let's look at another worked example together. Actually, if you feel confident, you could have a go at it first and then see how well you do. See whether you get the same answer as I do. Okay, so in this example we're looking at titanium chloride extraction, and reading the question I'm trying to find out the maximum theoretical yield of titanium that can be extracted from 100 grams of titanium chloride. So I've underlined the 2 species in the equation I'm looking at, and usefully it's a 1:1 ratio. That's going to make our lives a bit easier later on. So first stage, same as before, I'm going to need the MR value for what I'm starting with, the titanium chloride. So MR of titanium chloride is going to be 1 times 48 plus 4 times 35.5, which gives us 190. Next stage, I need to work out the number of moles of titanium chloride, because remember I can't go directly from masses. So moles of titanium chloride is going to be the mass, 100 grams, divided by the MR, the relative formula mass, 190. Now looking at my calculator, that gives me a bit of an awkward number. I'm going to make sure that I keep the whole value in my calculator so that I avoid rounding error. But I'm just going to write it down as 0.526. Next stage is to look at the mole ratio in the equation, and it's 1:1. So TiCl4 to Ti is a 1:1 ratio. Therefore, moles of titanium must be 0.526. Okay, next stage I need to convert to mass. So you remember from your equation, moles equals mass over mR, mass equals moles times mR. So mass of titanium is just going to be 0.526, and titanium just exists as atom, so times 48. And that gives me 25.3 grams, so 3 significant figures. So part B, the final stage is to work out percentage yield. So percentage yield equals yield over maximum theoretical yield. I've just calculated my maximum theoretical yield. I'm told that my yield is 20 grams, so 20 divided by 25.3 times 100, and I've got my percentage yield. So let's do that on the calculator. And it gives me 79.1%. And again, that's the 3 significant figures. Hopefully, having worked through this video clip, you now feel confident that you could calculate a percentage yield. It's fairly straightforward if you're given the actual yield and the maximum theoretical yield. A bit more difficult if you're not given the maximum theoretical yield, but hopefully those last 2 worked examples make you feel like you know the method. You may need a bit more practice though. It's one of those topics where the more practice you do, the better you'll get at it. And the method is the same every time. So I would suggest now, if you've got the chance, that you spend a few minutes going over some questions, maybe in your textbook or from a worksheet that you've been given from class.